FDM or frequency division multiplexing. Multiplexing means we want a single channel where you can send multiple signals. So this, what you can do, you have a channel, you can divide it into multiple parts. You say first signal go by this way, second assigned to you, now you go by this way, likewise. So once you can just combine and send it. So this is an analog technique, FDM, and this can be applied when the bandwidth of the link is greater than the combined bandwidth of the signal to be transmitted. That is, if you want to send, say, 3 signals, if you combine the bandwidth or the individual, you just combine, this should be less than the actual bandwidth available, then only FDM will work. Okay. So the channel frequency has to be higher than the individual frequency that are going to be FDM, multiplexed. So for FDM, frequency division multiplexing, it takes the advantage of the band pass or pass band transmission to share a channel. You know that pass band where we shift the frequency from the base band so that we have the signals are not centered around a centered zero frequency. So there will be a proper frequency on that will be the central frequency. So it divides the spectrum into frequency bands, each user having exclusive possession of some band in which to send a signal. That is, for example, this is the whole channel. We divide it. One of the signal will be given the dedicated part. This is assigned to you. The second signal will be assigned second band, or this is how the channel will be divided and exclusive position will be there. I'll give you an example of AM. You know about the radio transmission. So AM radio broadcasting is using the FDM. For example, the allocated spectrum from the boundary is around 1 megahertz. That is roughly around 500 to 1500 kilohertz. So this is total is, for example, we are taking AM 1 megahertz, 500 to 1500 kilohertz. Now multiple stations are there. So different frequencies are allocated to different logical channels or the stations. For example, one can be LA station, one can be some Wisconsin station, one can be some other, say Washington. So these are the different stations and they are allocated different logical channels, different frequencies are allocated like this, each operating in a portion of the spectrum. And here very important part is the inter-channel separation. For example, if you have two houses combined, there will always be a trouble, interference. If the houses are apart, there will be no problem or less problem. So here when we are dividing the frequency and assigning it, we have the inter-channel separation. This has to be great enough because we don't want any kind of interference between two adjacent frequency bands. Okay, so there are filters. It can limit the usable bandwidth. Say for a voice grade channel, it can be 3100 hertz. So voice grade channel, I'm talking about the telephone communication. Now this is 3100. I'm taking one more example actually. So this is 3100 hertz. When various channels or many channels are multiplexed, 4000 hertz is allocated per channel. Now you will feel the difference. 3100 and 4000. What is the difference? Around 900 hertz. Why this is there? Because this has to be there for preventing the interference among the adjacent band. This excess bandwidth is called a guard band. This is a guard band. This is necessary in FDM. Otherwise, there will be interference. Therefore, when you tune, you will see you have to tune a little bit so that the next station can come. So first, these voice channels, they are raised in frequency, shifted in frequency, each by some different amount, and then they will be combined because no two channels now occupy the same portion of the spectrum because every channel is assigned certain frequency which are different from other. But there will still be some overlap because we are using filters. The real filters will not have ideal sharp edges. There will be some. So here is an example of 3 voice grade telephone channels. They are multiplex using the FDM. So how does it work? Let us see here. The first figure, that is the A1, is the original bandwidth. Channel 1, channel 2, channel 3. Now the bandwidth are raised in frequency. That is, you can say we have made it shift. We have shifted it. So first one is shifted by a little bit. The second, this is the shifting I am talking about. And this is the only bandwidth raising in frequency. Second one like this. Third one we shifted it a little bit more, or you can say we have raised the frequency each by different amount, and now we are multiplexing it. So now you see these three channels, channel 1, channel 2, channel 3. How do they look? This is the multiplex channel you see here, and here is 60 to 64 you see channel 1, 64 to 68 channel 2, and 68 to 72 it's channel 3. So this is the whole procedure. You are dividing the whole spectrum, different frequencies, and allowing multiple channels to use that frequency with a guard band.